Imagine you are hosting a party for a group of new friends, and in your effort to impress these new friends, you decide to make some homemade brownies. You were planning to make the brownies the night before in order to keep it fresh, but with poor planning, you did not have enough ingredients and the store already closed. You are secretly a math genius, so you recognized the math present in baking and realized that this problem was solvable. Your original brownie recipe made 24 brownies, but there were only 10 guests arriving, so you decided to halve the recipe. Because you are a closet math genius, you understood that the very first step to solving this problem was using proportions. The recipe calls for 10 tablespoons or 1 1/4 sticks of unsalted butter, 1 1/4 cups of sugar, 3/4 cup and 2 tablespoons of unsweetened cocoa powder, 1/4 teaspoon of salt, 1/2 teaspoon of pure vanilla extract, 2 cold large eggs, and 1/2 cup of all-purpose flour. When splitting ingredients, you need to make sure to keep all the ingredients at the same ratios that they were originally. And this means that you need to divide each ingredient by the same amount, or in this case, in half. In having the recipe, you realize that in keeping the ratios the same, the brownie should turn out the same. With your math genius deductions, you calculate that the new recipe calls for 1/4 cup of flour, 3/8 cup and 1 tablespoon of cocoa powder, 1 egg, 1/4 teaspoon of vanilla extract, 5 tablespoons of butter, 5/8 cup of sugar, and 1/8 teaspoon of salt. After you have finished dividing the ingredients, you realize that there are some odd sugar and cocoa powder measurements. In order to easily measure the ingredients, you decide to use dimensional analysis to convert cups to tablespoons. While doing dimensional analysis, you need to make sure that you have equal ratios. With your math expertise, you know that the basis for dimensional analysis is canceling out like variables to convert units. In 1 cup, there is 16 tablespoons, so you would create the ratio as 16 tablespoons over 1 cup. First, you want to know how much tablespoons of cocoa powder 3/8 cup is. To arrange the problem, you create a ratio of 3/8 cups over 1, since that is the amount that the new recipe calls for, and then you multiply it by the tablespoons and cups ratio you had previously created. You can cancel out the cups using the big 1. The big 1 means that when the same values occur in a fraction in both the numerator and denominator, you can cross them out and replace them with 1, forming a big 1. You are left with 3/8 multiplied by 16. This can be simplified to 6 tablespoons. So you now realize that you need 6 tablespoons of cocoa powder. Now that you have found how much tablespoons of cocoa powder is needed, you proceed to do the same with sugar. Our new recipe requires 5/8 cup of sugar. And yet again, we set up the same ratio starting with 5/8 cups over 1 and then multiply it by 16 tablespoons over 1 cup. Using our previous knowledge, we can cross out the cups using the big 1. Now we are left with 5/8 multiplied by 16 tablespoons. This is simplified to 10 tablespoons, so we know that our new recipe calls for 10 tablespoons of sugar. Dimensional analysis can only be done correctly using ratios that cancel each other out. And using the big 1 lets dimensional analysis successfully convert units by creating ones that other variables are multiplied. Let's make this a little bit simpler. Take the equation 5/2 multiplied by 3/5. The two 5s are opposite sides of a fraction. Anything over itself is 1, so the two 5s make a 1. 1 multiplied by 3/2 leaves the answer as 3/2. This uses the concept of anything multiplied by 1 is itself. Math is an essential part of baking, from ingredient proportions to converting with dimensional analysis. But baking is only a portion of math's reach on seemingly unrelated subjects. Math is a large part of real-world subjects and can help solve many everyday problems outside of a classroom setting. When you open your oven to your freshly baked brownies, you can revel in your mathematic success.